I think this is a hard part of TMUA because you just do not go into this level of detail, anywhere near this level of detail in A-level maths on negating statements, which is what we need to do here. And it's something you're going to have to obviously learn by yourself. Of course, I'm here to help with this one. I remember doing this a long time ago, like at the start of a uni course, and doing truth tables and everything. But I wouldn't say I was a master of it, so it's actually something I need to work on. So apologies if this is not as polished as it could have been, and some of my other videos hopefully are. Okay, what I'm going to say though is if P implies Q, then we know that the contrapositive is true. That not P will imply not, sorry, not Q will imply not P. Now, if we add an extra one in, so Q implies P, then we can then use the contrapositive and say that not P is going to imply Q. And these will have the same truth value. So if the above statement is true, then the negation will also be true. And so what we need to do is take the above statement, just replace S by T, and then take the negation. So it's going to be that a set T of whole numbers is not stapled. That's the left-hand side sorted. If and only if, right, and then the tricky bit is going to be negating this. So it's going to be, what we essentially do is if it says for every, then we can negate that to say for some, because it means it's going to be for some whole number A, which is in T, there is not a prime number of A which divides. That is how I'm doing my negation. Um, So set T of whole numbers is not stapled if and only if for some whole number A, which is in T, there is not a prime factor of A, because that is the opposite of what we had before, or the negation of what we had before, which divides at least one of the number in T. So let's just looking for the options at this point. Because we've got for some whole number A, we can immediately rule out all these ones that say every. The other four have there exists, there exists, there exists, okay, which is the same as me saying for some. Now I've got the fact that there is not a prime factor of A which divides at least one other number in T. Let's just look for the options. This one is saying there's no prime factor of A which divides every other. That's not the same thing. Because we're just saying at least one. That bit doesn't change. You don't negate that or anything. And then F says there exists a number A which is in T such that there is no prime factor of A which divides at least one other number in T. That is exactly what I'm saying here. So that is going to be our answer. G then says it does not divide any other number in T. No, it's still that at least one. And then H says such that there is a prime factor of A which does not divide. Yeah, it's all really subtle, but actually our answer is F. We've just negated the every to make it some, and then we've said there's some where it's there, although there did exist before for the stapled, now there doesn't exist, or there is not a prime factor. We don't change anything else. So F is our answer. Just very quickly, I want to share the work solutions because I think they explain it really well. So they negate it and they write, yeah, not stapled, the if and only if, and then it's not the case that for every. I like that. That's another way to think about it because that means they're um, that means for some. That's what we would change that to. And then there exists here, we're going to change to there does not exist. So then it becomes exactly that. It becomes there exists here, and then there does not exist. But everything else, as you can see that they've highlighted here, stays the same. All right, it does take a bit of time to get your head around this, and there's not a lot of questions on it that I've found. So, but if you found other good sources, then please let me know. Well done with this one.